Okay, girls. Sorry, Amira. Yes, we did finish 10.4. The only thing that's left is some of the questions. I will leave them to you to complete. Yeah. Please complete them. They're important. I think I did. I gave you all the rules. Remember, there are basically 8 different important results. And make sure you know those 8 results. So this number 8 should be in your mind. You need to know each one of them because you will see questions in your tests and final exams and so on about 10.4. It's an important section. Now I want to go to yes. If you look at the syllabus, which is actually in Blackboard, if you go to course documents, the first file you will see there is the syllabus. I put some office hours there on, I think, Tuesday and Wednesday. If those hours are not suitable for you, I think I already mentioned this, please get in touch. I can find some other time to talk to you. Okay? Yeah. So there are 2 office hours. I will open from next week. I will come and open sessions during those hours. You want to come in with any question, you want to join, you are welcome. Any question you want to ask, I will be able to explain it to you, and hopefully you will be okay. So please complete the questions we left in 10.4. They're important. If you have any issues with those, let me know. So next section, strangely enough, is not 10.5, but 9.1. If you look at the syllabus, it's actually 9.1. I want to mention, I want to explain what this, do you know at all what parametric equations are? Any idea what parametric equations are? No, okay. Okay, that's fine, no problem. Let me explain this idea of parametric equation. Yeah, the parameter is basically a variable which we usually use as, which we call it t usually. The parameter is t. It's a bit like time, yes, but yeah. So let's say, for example, you have the normal equation y equal x squared. Yeah. This is what? This is a parabola, huh? This is a parabola. Like this. So it's normal, no problem. However, sometimes, so this is like an equation between a relationship between x and y, yeah? Y equal x squared. Where are the points which satisfy this? Well, they are on this parabola. The point 1, 1, yeah, 0, 0, yeah. When x is 0, y is 0. When x is 1, y is 1. You will have a point 2, 4, etc. etc. All of these points are on this curve. No problem. But the same parabola, I can describe it in parametric equations. The parametric equation of this parabola will be, yeah, this is a new, not a chapter, yes, it's a new chapter, yes. I don't know why they put this section 9.1, basically between 10.4 and 10.5. So I will do 9.1 and then come back to 10.5, because I think we use a little bit this idea of parametric equations in 10.5. So we just make sure you know what parametric equations mean. So the same parabola here, I can describe it not by this equation. Yes, I will of course post the notes. Yes, 9.1. I have the solutions. I will post them. Yes. So the same parabola can be described in this way. Suppose you call x equal to t. So you introduce a new variable t, which is called the parameter, and x will be t, and y will then be equal to t squared. And t, the parameter t, is basically a real number like that. So for example, when t equals 0, what point will you get? If you substitute in these two equations, what will you get? The point 0, 0. Yeah. So basically, this point will happen at t equal to 0. If t is 1, then x, of course, you substitute here, you get x equal t, but so that's 1, and then 1 squared is also 1. Suppose you take t equal 3. So what point will you get on the curve? 3, 9. Yes, 3, 9. So we get the point 3, 9, etc. So that basically is what the idea of parametric. T is the parameter. So T is what we call the parameter. So parametric equation are like this. X equal a certain function of t, y is also another function of t, and then you get the points xy, yeah, as t varies, as t changes, you're getting different points. T equals 0. For example, if I have t equal -1, then what point I will get on the curve? If t is -1, you substitute, you will get -1, 1. Yeah, -1, 1, etc. So you have different t equal -1 here. Yeah. So that's this point. T equal 0, t equal 1, t equal 2. So as t changes, as the parameter changes, you are getting different point along the curve, like that. So that is the idea of parametric equations. So parametric equations are x equal a certain function of t and y equal a certain function also of t. So these are called the parametric equation. T is the parameter. Yeah, t is what we call the parameter. Now, so the question in general is like this. The question is, suppose I give you parametric equations. Suppose you look at this parametric equation. Sorry. Yeah. X is equal to, let's say, t, and y is t to the power of 3. And I want to know, what is this curve here? How can I graph this curve? Yeah. What sort of curve is this? Well, the way we do that is you basically change this equation, yeah, change this equation into an equation with x and y only. So now this t is x. So therefore this t, I can replace it with x. So I'm getting, so these parametric equations are the same as y equal x to the power of 3. Now x to the power of 3, I know is a curve. Yeah, I know how to graph it. x equals to the power of 3 is like this. So this is, in fact, these parametric equations are describing this curve. Well, again, we can check when t equals 0, we get the point 0, 0, which is this point. When t is 1, we get the point 1, 1, which is this point, and so on and so forth. So the way we, if you are given parametric equations, and you want the graph, then you go and find an equation between y and x, and then you can graph. So that's the different steps. So you have your parametric equations. You find an equation between y and x, and then you can use this equation to graph the curve. So let's have a look at. So sketch the plane curve defined by the parametric equation. So here are parametric equations, and I want to graph this. So the way we do that is like this: x equal 2 cosine t, y equal to sine t. I'm going to find a relation between x and y. I'm going to find an equation between x and y. So the way we do that, put this, divide both sides by 2. So x over 2 will be cosine t. Now y over 2 will be sine t. Yes. Now we know that, remember from trigonometry, that cosine squared plus sine squared is always equal to, sine is equal to 1. Yes, exactly. So that means x over 2 squared plus y over 2 squared is equal to 1. So here is, after that, I need to change this equation a little bit. So I get x squared over 4 plus y squared over 4 is equal to 1. Then multiply both sides by 4, and you get x squared plus y squared is equal to 4. Now, I can recognize this equation now. What is the shape of this curve? It's a circle. Exactly. So now, because I have this equation between x and y, I recognize this as the circle of radius what? What is the radius of the circle? 2, and it is centered at the origin. So we get this here. So this is the curve. Now, t goes from 0 to 2 pi. That means we are moving along this circle maybe only once. Let's say we take, for example, when I take t equals 0 and I substitute here, so x will be 2 cosine 0, which is 2, yeah, and y will be 2 sine, yeah, so I'm using this, 2 sine 0, which is 0. So I'm starting, yeah, I'm starting with this point here. So that's, I'm here when t is equal to 0. And then I can check maybe at t equal pi over 2, what will be x if you substitute? Yeah, x will be 0. Yeah, good. And y will be 2 sine pi over 2, which is 2. So 0, 2. So I am here now. I reached this point when t is pi over 2, and so on. So you can see that we are moving when t is pi. I think we will be here when t is pi 3 pi over 2. We will be here, and then when t is 2 pi, I come back to the same point. So I am actually moving like this. Okay, so that is basically the sketch. Sketch means graph, yeah? What is the graph? Well, the graph is a circle. A, with A, it's a full circle. How about t only from 0 to pi? What happens when t is only from 0 to pi? It's half a circle. Thank you. Yes. So in this case, the graph is only half the circle. So I'm getting this here. When t is 0, we are here. And when t is pi, it's the end of our journey. It stops there. So this is 2, this is minus 2, this is 2. So we are moving like this. So that is basically the way we sketch the graph if your equations are given in parametric form. So you try to find an equation between x and y which we can recognize, which we can know, and then graph that. Same thing here. Identify the plane curves. This time we have these two parametric equations. What is it? Is it a circle? Is it a parabola? Is it etc. etc. So what is this curve basically? Okay, to do that, again, we're going to find an equation between x and y. Yeah. Now, the way we're going to do that is again using the trigonometric identity sine squared plus cosine squared equal to 1. So let me write the parametric equations. 2 sine t, y is 3 cosine t. Like I did before, I will find the sine t from the first equation. So it will be x divided by 2. So x over 2. The second one, cosine t, is y over 3. Now, that means x over 2 squared plus what? Plus, yeah, y over 3 squared. Good. Again, this should give us 1. Exactly. Thank you, Nanda. All right, great. So let's see what is this. What is this equation now? Between x and y, normally I know roughly what are the curves. Yeah. So this will give us x squared over 4 plus y squared over 9 equal to 1. Do you recognize this as an equation? Do you know what this is? Any idea? No? Okay, the problem now, of course, the problem this time is that it's not the same number like before. Before it was 4 and 4, so we could multiply both sides by 4 and we get the equation of a circle. This time the numbers are different. It's not a circle, unfortunately, because the numbers 4 and 9 are different, so they're not, it's not a circle. Well, actually, this is what we call an ellipse. This is an ellipse, like this. It's like an egg-shaped, like this. Yes, it's an oval. Yes, it's. But in mathematics we use the word ellipse or an. Okay. And you can now. So this is x and this is y. It goes. This ellipse goes through the point. This point here. When y is 0, you can see that x is going to be 2 or minus 2. And when x is 0, you can see that this graph will go through minus 3 and 3. So this is actually the graph of these parametric equations. It's an ellipse, yeah, like that. Centered at the origin, because there's nothing there, it's x alone. So it's an ellipse centered at the origin. Okay, t from 0 to 2 pi, I think you can check that when t is 0, you get the point. Okay, all right. I think this is not. When t is 0, we're getting the point 0, 3. So we are starting. Yeah. If you put t equals 0 and you substitute in these parametric equations, then we get x will be 0 because it's 2 times sine. Yeah. And the y will be 3, so 0, 3. So we start from the point 0, 3, which is here. So at t equals 0, we are here. And then you can check different values of t, and I think you will move around until you come back there when t is equal to 2 pi. So that will basically show you what's happening there. Let me just complete by doing the part B there. Part B, we have two parametric equations this time. So x, slightly different from this, because we're adding the point 2 plus 4 cosine t, and then 3 plus 4 sine t. So y is 3 plus 4 sine t. Okay, now what we're going to do is, again, I will get the cosine from here. Yeah, so we will move the 2 and divide by 4. So cosine will be x minus 2 divided by 4. And the sine will be y minus 3 also divided by 4. So we move the 3 and divide by 4. After that, we're going to use the identity again. So that means x minus 2 over 4 squared plus y minus 3 over 4 squared is equal to 1. And then that means x minus 2 squared plus y minus 3 squared is equal to, what do you think? Not exactly 4, not 4, Amira, Nada. Can you check again? 16, yes, thank you, yes. It will be 16 because you have a 4, but you have to square that. So it's going to be 60. Now, what is this shape, girls? What is this shape? Do you recognize it? Do you recognize this equation? It's just, okay. In 3 dimension, it's like a sphere if you add the z. But in 2 dimension, what is it? Just in 2 dimension only. Because we only have x and y here. Huh? Not an ellipse, no. It's a circle, yes. This is a circle. This is a circle, but not centered at 0, 0. What is the center of this circle? So it's a circle centered at 2, 3. Yes, thank you, Noor. Yeah, the centered at the point 2, 3, and with a radius of 4, with a radius of 4. So basically, if we want to graph this, the center will be at 2, 3 here, and the radius is 4. So basically, kind of something like this. I'm not sure. Yeah, 2, 3 here. Yeah, x. Yes. Okay. Okay. Sorry, sir. That's okay. Important thing is, you read again, you try and understand. I'm not expecting you to understand everything here. Of course, if you do, that's great. If you don't, then it's not a big issue. You just need to read the notes again and so on. Yes. Okay, so that is where I will stop today. I think I already you already have an idea about these parametric equations. So you have parametric equations. You want to identify what is it. Is it a circle? Is it a parabola? Is it a line? And so on. Then, it's like this. Okay, thank you very much for your attention, girls, and we will stop here. Thank you for all your hard work. All right. Okay, great. Okay then, you have a nice weekend and take care of yourselves, and I will see you next week, inshallah.